Hello students, I'm going to talk extra loud so you can make sure, or so the video can capture my voice. Before you do anything with math, I'd like you to pause the video and go grab your parent or guardian, because I want to make sure that actually you are watching this video along with your parent or guardian. And parents, to make sure that you are watching this with your parent or guardian, I would like you to ask the following two questions. So yes, I guess I'm giving you homework, just two questions. First question is, what is your favorite restaurant, and these are going to be popping up on the video, restaurant in Brownsville? This is just a test question, but also I need to find better places to eat rather than just McDonald's. And then second question is, how can you support your child at home? One great way that you can support your child at home is by watching these videos, which are not too long. The longest they ever are about 15 minutes. And you can watch them along with your student, and you will learn a couple different things. You will see what we are doing in class. This is from videos, what you'll learn from videos. And you will also learn the math so you can help your child. So this is child, period. This one is the test question. This one I would like you just to, I kind of gave you some ideas of the answers, but other ways that you can support your child at home. Okay, so let's go ahead and dive into the math. Now, parents, the students know this, but this problem here is 1G. G means guided, so I guide the students through this problem. I model this problem. And this is 2G here. This one here is 1S. The students will be doing the S problems. S means student-led. And this one here, it will be 2S, but we will get to those. Okay, so let's go ahead and dive into the math. So 1G. Through the first 11 games of the season, the Lions won 7 games. If they played 95 games in an entire season, about how many games will the Lions win if they keep winning at this rate? So in order to solve this, we're going to have to set up a proportion. Another thing that's important, worth noting, is about approximately. So we're probably not going to get exactly one of these answers, but we're going to get something close. So we're going to choose the closest answer. Okay, so we can set up a proportion which is 2 equal ratios or fractions. 2 equal ratios or fractions, and a ratio is a comparison between, B/W is a note-taking shortcut, between two numerical quantities. This is all review. The students should know this. 2 numerical quantities. So, through the first 11 games, they won 7 games. So there's our first ratio right here. 7 over 11. I'm also going to label my units. So they 7 won, and then 11 is total. And this is going to be equal. If they played 95 games, how many games will they win? So 95, this is a crucial decision here. Are we going to put it here or here? Is it the total games won in an entire season? No, it's going to be the total number of games. And then here will be X. So we're trying to predict, using math and proportions and this equal ratio, this sample, how many games they will win. Okay, now this is one correct proportion. Notice that in the vertical alignment This is one ratio, this is one comparison, and then this ratio is another one. But now look at the denominators, both are total games, and the horizontal alignment here in denominator, total games, and horizontal alignment, like horizon, flat, is won games. So we've got vertical alignment and horizontal alignment. So this is also review, but there's different ways that we can set up a proportion. Another way we could do it is have here the won games, compare that to the total games, and I just need to make sure that the horizontal alignment will also stay true. So the won games, let's see, we're just comparing these here. So we have the 7, which is the yellow in the yellow ratio, over x, and then we're going to be comparing the total games, which are these two quantities, and the 11 is in the yellow ratio, and then the 95. So both of these ratios could work, and there's actually several different kinds. I could also flip these two ratios, so it would be 1195 is equal to 7 over x, but these are the two basic ones here. Notice that there's alignment, vertical alignment and horizontal alignment in both. So the most important thing about proportions, proportions must have vertical and horizontal alignment, in the units and ratios. Okay, so now let's go ahead and dive into this problem. We're going to solve actually both of them, and I'll show you why they're the same. So 7 over 11 is equal to x over 95. 7 over x is equal to 11 over 95. So the way that we're going to solve these proportions, this is review. We're going to cross multiply and have the products be here. So it's going to be 7 times 95. That's not 7.95, 7 times 95 is equal to 11 times x. And if we do it here as well, 7 times 95 should equal x times 11. So, two different proportions, but we set up the problem the same way. We're still going to multiply the 7 and 95, and we're also going to multiply the x and the 11. So let's just go ahead and keep doing it with this one right here. We don't need to do both. 7 times 95, 7 times 5 is 35, 7 times 90 is 630, 5, 6, and 6. Okay, so we have 665 is equal to, I can rewrite 11 times x as 11x. So now we have our old friend, a one-step equation. We just need to do the inverse operation by dividing both sides by 11. These will cancel here. And now I have x is equal to 665 divided by 11. And now I'll do that division right here. 665 divided by 11. 11 goes into 66 6 times. 11 times 6 is 66. Minus a 0, bring down the 5. 11 goes into 5 0 times. 11 times 0 is 0. 5, I'll do this. 5 minus 0 is 0. Bring down the 0. Decimal point, star line. 11 goes into 50 4 times. And it will go on. So this here is the value for x. X is equal to 60.4. Actually, I'm going to make this equation sign squiggly, which means approximately. So it's approximately 60.4. And then what are the units here? Well, we were trying to solve for x, the total number of won games. So our prediction about how many games will the Lions win at this rate, our answer is going to be A, 60. All right, now students, what I'd like you to do, please complete problem 1s. I like this problem because this is true. Kobayashi is the world leader in hot dog eating competitions. He ate 60 or 50 hot dogs in 12 minutes. How many hot dogs could he eat per hour? What was the Kobayashi's rate of eating hot dogs per hour? Notice that we have minutes here. Per hour, maybe some students might put 1 in the ratio, but you need to figure out how many minutes are in an hour, and that's going to be 60 minutes. So use 60 minutes here, set up a proportion, make sure it's vertically and horizontally aligned, and then solve for x. All right. The question should be popping up any second now for 1s. Now I'm going to model the last problem, which is 2g here. George can bench press 7/10 the weight that Drew can bench press. If George can bench press 126 pounds, how many pounds can Drew bench press? So the key here is this 7/10. This is the conversion rate. This is how much of the weight George can bench press of Drew. So it's kind of like this. This is George, not quite as strong, and then Drew, this is Drew. He's much stronger. He's got bigger biceps and bigger triceps and everything. So this here, so this is George's weight. See how it's horizontally aligned. And this is Drew's weight. So you could kind of think of it like if George could lift 7 tires, then Drew could lift 10 tires. Or if George could do 7 push-ups, then Drew could do 10 push-ups. So we can use this ratio here, and then this one numerical quantity, and plug it somewhere into, substitute it somewhere into the proportion, and then solve for how much we think Drew can bench press. So the proportion could be something like this. I think this is the most intuitive one. 7 over 10, and I'm going to write 7 George and 10 Drew is equal to, now we know that George can bench press 126. So the key is, where am I going to put the 126? Am I going to put it here aligned with Drew? And the answer is no. It's going to be here aligned with George. So it's George BP bench press. And now we're going to be solving here for Drew bench press here. So now once I have this proportion, well, let's just look at our diagram. So the George, or the Drew here, the stronger Drew is here, and then the smaller George is here. So everything's nice and aligned. So what we'll do is we'll multiply diagonally, and we'll set the products equal to each other. So we have 7 times x is equal to 10 times 126. So we'll have 7x is equal to, now if I'm multiplying by a power of 10, I just need to move the decimal place 1 space to the right because it's bigger. So 126 times 10, you can multiply it out. But I know that it's going to be 10 times bigger, so if the decimal point's here, then I'll move it 1 place to the right to make this number bigger. So it's going to be 1260. 1260. Now I've got my old friend, one-step equation. Inverse operation, what I do to one side, I must do to the other. That's right. Thank you very much, students. I'm going to divide by 7 on both sides. These will cancel. And I have x is equal to 1260 over 7. And this division should give me my answer. 7 goes into 12 one time. 7 times 1 is 7. 12 minus 7 is 5. Bring down the 6. 7 goes into 56 8 times. 7 times 8 is 56. 56 minus 56 is 0. And now bring down the 0. 7 goes into 0 0 times. Great. So now we have x is equal to 180 pounds. So how much can Drew bench press if George can bench press 126 pounds? Well, it's 180. All right, now students, if you could please solve this problem. So I did two problems that don't have relevance in the real world. You're doing two problems that do have relevance in the real world. I think this is an interesting one, and the Kobayashi is also relevant and interesting. The amount of nitrogen in the atmosphere is in a ratio of 26 to 7 to the amount of oxygen in the atmosphere. If nitrogen makes up 78% of the atmosphere, what percent of the atmosphere is oxygen? Interestingly, of all the gases that are in our atmosphere, nitrogen does make up about 80%. I can give you some more science facts, but oxygen is, even though that's what we breathe, is not the most common gas. The reason why dinosaurs and animals living tens of millions of years ago and hundreds of millions of years ago were much bigger than the animals today was because there was a much greater amount of oxygen. So, just interesting science fact, if we had something like 50% oxygen, humans could be about 10 feet tall. They could be much, much bigger because oxygen is the gas that is necessary to supply our muscles with energy. All right. Thank you very much, everybody. And parents, thank you very much for also following along.